Hi, welcome to the Chapter 5, Section 5 video. And what we're looking at is an indirect proof. And an indirect proof proves a statement or conclusion to be true by proving the opposite of the statement must be false. You can also call this proof by contradiction. Okay, so to write an indirect proof, you're going to have 3 steps. So these are your 3 steps. These are very, very important to you. The first step is you assume the opposite of what you want to prove. So you negate your proof statement. Then step 2, you show that this temporary assumption leads to a contradiction, and you're going to do that by following the given and seeing where it leads you. Step 3, you're going to conclude that the temporary assumption must be false, and therefore what I want to prove must be true. Okay, so at the bottom of the page you'll see an example, and in this example we walk through the steps again. Negation, statements that lead to a contradiction, and concluding the temporary assumption is false. Okay, so let me zoom in a little bit here. Hopefully this will work. Just so we can see the writing a little bit better. Okay, sorry about that, if anybody's dizzy. Okay, so angle A and B are not complementary. That's what we're starting with as our given. And we're trying to prove angle C is not a right angle. Okay, so step 1 is the negation. So you take your proof statement, which is right here, and assume temporarily the opposite. So the opposite of not a right angle would be that angle C is a right angle. Okay, so then at that point, looking at our triangle, if angle C is a right angle, then the measure of angle C must be 90 by definition of a right angle. Notice this form that we're using is paragraph form for a proof. We're saying our statements and giving our reasons, but we're doing it in sentences rather than columns. Now, I also know angle A plus angle B added to the measure of angle C must be 180 for this triangle because of triangle angle sum theorem. I then substitute 90 for angle C, and if that's the case, that leads to angle A and angle B must equal 90. Well, if 2 angles add together and equal 90, that means, of course, they're complementary by the definition of complementary angles. But wait, go back up to the top. You're given your statement that must be true is that angle A and angle B are not complementary. So we have contradicted the given. And therefore, if that happens, the assumption we started with that angle C was a right angle must be false, and we conclude angle C is not a right angle. Okay, so in leading up to this, we're going to go ahead and look at the examples on pages 2 through 4, and then we will see how we're doing when all that's done. All right, we're continuing on to page 2. Okay, on page 2, we're being asked to write the temporary assumption you would make as a first step in writing an indirect proof. And again, the first step of an indirect proof is to negate the prove statement. Whoops, that's off my page. I'll slide that down so you can see it. So negate the prove statement. That's the first thing we want to do. Okay, so we look here. Great, there's our given, there's our prove. So our prove statement says Q is a factor of 34. So I want to write the opposite of that. So I would temporarily assume and again, the opposite of Q being a factor of 34 would be to temporarily assume Q is not a factor of 34. Okay? For the second one, our proof statement is xy, the length of xy plus the length of segment xz is greater than the length of segment yz. So, our proof statement says we want to prove this is greater than. So what's the opposite of greater than? Some of you may be saying less than, but don't forget about equal to. So we end up with temporarily assume. And again, the opposite of this would be that xy plus yz was less than or equal to yz. Okay, go ahead and try number 3 and number 4 on your own, and we will check on those in class. Okay, so moving on to example 5. You may want to stop the video and finish examples 3 and 4. If not, we will continue. So we're identifying the two statements that contradict each other. Okay, so if we look at A, we're being told triangle ABC is acute. And when you read that, you should think to yourself, okay, acute means all angles less than 90 degrees. Great. We're being told in the second statement, triangle ABC is scalene. So scalene means, of course, no sides congruent. Okay, well, the first statement was about angles, second statement was about sides. So far, no contradiction. The third statement says triangle ABC is equilateral, and equilateral means all sides congruent. Well, anybody care to guess which two are contradicting each other? That's right. No sides congruent and all sides congruent are definitely contradicting each other. Okay, in the second one, you're being told, first statement, angle B is less than or equal to 90. Great. Second statement, angle B is acute, and we already know acute means less than 90. So far, no contradictions. Third one, angle B is a right angle, and a right angle means, of course, equal to 90 degrees. So, which two of those statements are contradicting each other? That's right, 2 and 3. You can't be less than 90 and also equal to 90 at the same time. So those are the contradictions. Okay, we'll do one more of these. Let's go ahead and take a look at statement 1. It says segment FA is parallel to segment AC. Great. Parallel means you are in the same plane and you never intersect. Statement 2 says segment FA and segment AC are skew. But skew means you're not in the same plane and you also do not intersect. And statement 3 says segment FA and segment AC do not intersect. Well, do not intersect works for both statement 1. We're back again, sorry about that. The two that are contradicting each other are parallel and skew. You can't be both at the same time. Okay, and I'd like for you to please try example D and example E on your own, and then we'll see in class how you did. Great, thanks. Oops, so we're switching to page 3. No breaks there. And for page 3, what we're going to do on example 6 is we're going to fill in the blanks to complete the indirect proof. So we're given that we have right triangle ABC, and we're given that angle B plus angle C is equal to 90. And I'm going to go ahead and draw a picture to help me see this. And we're trying to prove that angle B plus angle C equals 90. So angle B and angle C must be the acute angles, and A must be the right angle. Okay, so assume temporarily that the measure of angle B plus measure of angle C, again, we want to negate the given, so we would say is not equal to 90. If measure of angle B plus measure of angle C does not equal 90, then what happens when I add up A plus B plus C? When I add those three angles, then if B and C don't make 90, and you're adding that to 90, well, we're not going to equal 180. But according to the triangle angle sum theorem, we have to add up to 180. But we don't. And this contradicts the previous statement, so the temporary assumption is false, and therefore we know the measure of angle B plus the measure of angle C must really be equal to 90. Okay, so for example 7 and example 8, we will take a look at these in class. I'll give you guys, you'll have an answer key available to you. I would like for you, though, to try number 7 on your own, and I'm going to help you guys out. Your first step of your indirect proof is going to be to negate. So right now, our proof is segment EF is not congruent to segment DE, so we're going to temporarily assume that segment EF is congruent to segment DE. And then, as we say, follow that statement. If that statement is what we're assuming, now I'm going to go back to my givens. My givens say triangle DEF has angle D not equal to angle F. If these two angles are not equal, then what must be true about this triangle? So with that in mind, go ahead and try 7 on your own and stay classy.